The construction industry has reached the age of digitalization. What had started with the invention of the computer by the civil engineer Konrad Zuse developed into many milestones in the construction industry. One of these major changes in the planning culture of the building industry is the working method, building information modeling, BIM, where a digital model of a structure with a high depth of information is created. Follow the work of a young team that has commissioned the design of a building of the Technical University of Munich by using the BIM approach. This method allows them the merge of several disciplines together within a unique 3D model. Above all, communication is an important part of successful BIM planning. In the case of international cooperation, this cannot always be guaranteed. In order to reduce risk, improve quality, and deliver projects on time and on budget, the team decided to use BIM 360 as a unified platform connecting project teams together. From everywhere to any time you can work on a digital model. This makes the work under the planners more efficient.
Hi everyone, I'm Alessandro and I was in charge to the design of the rural building. Being an architect means dealing with a huge responsibility. When I started designing a project, I started asking myself, what does this place need? What can I do to create value? The site in Wendelstein is unique. You have a 360 view, spacing from a deep valley on the south to the Wendelstein top to the north. You are completely surrounded by nature. And that's the feeling I want to give to everyone coming to our mountain office. It doesn't matter if you are coming there for a meeting, passing by during a trekking, or just a ride for your skiing weekend. Our mountain office will provide you everything you need. The other space of the refuge, delimited by columns, will offer shelters to trekkers, also when it is closed. As you enter, locker air shelves will allow you to relieve yourself from your heavy equipment, boots and skis. The first floor is where office and refuge lifestyles merge together. The space is open, allowing people to freely move around from the kitchen to the meeting room. Just like creativity flows as we move along. On the second floor, we wanted to provide a more intimate space. The central fire pit, which serves also as a heating system, will give you that cozy atmosphere that you were looking for going outside the crowded city. Talking about the rooms, there aren't suites, business or economic options. There are just two types of rooms, for 6 or for 8 people. Are you alone with sunsets, or are you a morning person? And if you are brave enough to go out and stare at the night sky, the balcony will fulfill your desire. But all this thinking needs to be put in practical. That's why we also focused about construction technology. Wood resulted to be the best solution, both for structure and for cladding. Building in such an altitude means no street for transportation. We designed it with prefab cross-laminated timber structure and lightweight and small materials. Has to be assembled directly on site. That ensures us to have a quick and easy mounting.
Hey, my name is Daniel, and I was responsible for the structural analysis of our building. Working with our team and thanks to the BIM method, we created a great building. For the structural analysis, we used the software RFEM by Global. RFEM interacts with Revit using a direct interface. In this way, it is possible to create new models and adjust modifications in both directions. Once the model in Revit is created, the analysis model can be changed easily and exported to RFEM. It was very important to mark the structural elements as a part of the structure in Revit. Otherwise, walls, beams and slabs were missed during the export. First, I checked the system in RFEM concerning the completeness. Is everything there, or has something been forgotten, like walls, columns, beams and so on? If yes, I added these structural elements to the model. Because both material libraries did not match, they had to be adjusted afterwards. Then the loads were created. In this way we have a lot of snow on the roof, so the roof had to be very stiff. we decided that we take a CLT roof which can carry the snow load. With the help of the CFD software or wind simulation of Global, we could also generate wind loads very easily. The software is used for numerical simulations of wind flow. It was possible to watch the different pressures as well as the velocity vectors. Moreover, we were able to transfer the wind loads back to RFEM as survey pressures. After finishing the modeling and applying the loads, we calculated in order to get the results for the design of the structural elements. With a thickness of 160 mm, the CLT slabs are able to carry the living loads and have also a low deflection. The designs of columns and beams are met. They are made by glue-lame timber and can carry a lot of compression forces. Also, the walls made by CLT were designed in order to transfer the loads to the bottom. Finally, the thick roof of 220 mm had enough resistance to bending moments and had also a low deformation. Thanks to BIM, I would say that we save time, because the model is created at the same time in Revit. So the communication between the architect and structural engineer is better.
Hello, my name is John, and I was responsible for the energy efficiency and sustainability of our building project. From the weather data gotten from the closest weather station to our proposed building site, I know we are building in a predominantly cold environment, and this goes a long way in affecting our building envelope and the percentage fenestration our building will have. Considering this, we constructed our building envelope on Revit using the information we got from datahost.eu. Firstly, to ensure our material can be sourced here in Germany, and secondly, not to achieve the thermal properties we want our envelope to have. Also, our building is not located in a dense urban area, so supplying district heat to this location will not be economical. That is why we resorted to the use of wood burners, and particularly an high storage heat pump for the main source of heating our building space. And this is mainly because it requires no regulation for this installation here in Germany, and it is readily available to purchase. For the fenestration, we try to achieve adequate daylighting in the space that needs it the most, and also created a good connection for the people with the external environment. This was mainly in the southern side of our building, which had little effect on our energy performance. After running the life cycle analysis, we tried to make the building more economically friendly by replacing materials that have the most adverse effects with more sustainable ones wherever it was possible.
One of the biggest challenges in the construction industry is the coordination of all disciplines. Thanks to the Solibri model checker, the team was able to communicate in a better and clearer way. In that way, it was easier to find problems by clash detections and to solve these issues.
John. Hey, John. Hey, can you please synchronize your model?
I just did.
Yeah, but you are the ownership, so please synchronize it. Yeah, every time. Come on.
One of the main challenges we faced in our BIM project was the fact that I have to wake up in the morning and call Daniel. Hello, Daniel, synchronize your model, please. Like, S is so through. Come on. That's one of our challenges in our project.